Hello, geography class. This is going to be a video for you to take some notes on climate and vegetation. Um, so just take out your notebooks, take out your study guides, whatever you want to use. Um, this material will be on the upcoming unit test next Thursday. So yeah. Um, I'll try to not make it too terribly long. There will be some slides that I'll try to switch back and forth from so I can draw some things on a whiteboard for you guys. And yeah, don't look at my YouTube channel if this is posted on YouTube because that's embarrassing and they're all videos for school. But if you want to subscribe, no, don't subscribe because that's weird. Okay. Anyway, so let's go ahead and start. We're gonna look at weather and seasons and fluctuations and changes in that first, and then we're gonna go into climate. So to start, seasons gets a little bit tricky because it involves like space and planets and all things up there that um I don't really pay attention to because it freaks me out a little bit. But anyway, so the sun is in the center of everything. So I'm going to draw this out. So this is the sun. Sun. All right. So the Earth revolves counterclockwise wise around the sun. So I'm going to draw that. And I hope that it doesn't look funky because it needs to be like flipped or whatever. Um, so the Earth revolves counterclockwise around the sun. And Earth is also tilted at a 23.5-degree angle. So Earth is not just like there's the North Pole and the South Pole. It doesn't go straight up and down, it's tilted. So that makes things a little bit more funky. All right, so that's where we're at this point. So this is going, so when we have the most solar energy hitting the Earth is when we're going to be in the season of summer. So this is going to be our northern hemisphere, and this is our southern hemisphere. So Earth is kind of split like that. In the winter time, this would be winter in the northern hemisphere. And that is because the sun's rays are coming to Earth. Okay, but since the northern hemisphere, since Earth is tilted, I should draw the line tilted. So since the Earth is tilted like so, the southern hemisphere is going to be closer towards the sun and receive more of the sun's solar energy and light than the northern hemisphere. That is why if you've heard winters in like northern parts of Alaska and northern parts of like Canada and the North Pole, when it's winter time, they only have like a couple hours of light, if that. In the winter time, um, it's going to be dark all of the time, 24 hours a day. There's going to be darkness because of this tilt here. Now, if we go to the other side, where it's summer, it's going to be summer in the northern hemisphere and winter in the southern hemisphere. And it's for the same exact reason. Because on this side, when it's summer, the southern hemisphere is getting less light less solar energy from the sun than the northern hemisphere. So it's going to be colder in the southern hemisphere, warmer in the northern hemisphere. They're going to get more light. At this point, the opposite happens in like Alaska, Canada, and stuff. It's going to be light all year long. So they have like super like dark curtains and stuff to like help people like distinguish night and day, or else they'll just be like out hiking at like 3 in the morning and be super funky and weird. But that's how that works. So that's a little bit of summer and winter for you, but it gets trickier because we have two lines of latitude. There's going to be one on either side of the equator. And remember, the equator is at 0 degrees, right in the center of Earth. So 0 degrees splits Earth right in half horizontally. And then you have these lines of latitude above and below it. And these are called the Tropic of Cancer and the Tropic of Capricorn. So I believe the Tropic of Cancer is going to be the one in the northern hemisphere. The Tropic of Capricorn is going to be the one in the southern hemisphere. If I'm wrong, then I'll get to that later. So, yeah. So that's what kind of helps us measure our seasons. So I'm going to draw each of these. Okay, so up here at the top is going to be spring. I'm going to try to make this make as much sense as possible through a computer. Okay. So up here is spring. And spring and autumn, we know that the seasons change from spring and autumn through this thing called the equinox. Okay, and what the equinox is, so remember how I said that here in, this would be spring, summer, winter. Oh, I have the earth tilting the wrong way. Oh well. The information stays the same. So in summer, when the northern hemisphere is going to be getting more light, the days are going to be longer. So we all know that it doesn't get dark until like 8 o'clock in the summertime. It's super cool, or like 9 o'clock, and we all get to stay out and like have fun and stuff. And then in the winter, it gets dark at like 4 p.m. and it's ridiculous and makes us sad and like depressed. Well, it's because of the solstice and the equinox. So in the summer and in the winter, we have a solstice. And the solstice is the point where we are going to get the most or the least amount of sunlight in the year. So summer solstice is when we get the most amount of sunlight, is when the most amount of solar energy is able to hit the earth in our location at the right time. That's the summer solstice. After the summer solstice, days start to get shorter and shorter and shorter and shorter until we get to the autumn equinox. So days are getting shorter and shorter, shorter and shorter and shorter and shorter, and then we get to the autumn equinox. And what the autumn equinox is when the amount of hours that are in night and the amount of hours are in day are exactly the same. So 12 and 12, perfect. And then after the autumn equinox, days still keep getting shorter and shorter and shorter and shorter and shorter and shorter and shorter until we get to the winter solstice. And then there's like 8 hours of day or something, like ridiculous. The shortest day of the year is winter solstice. And then after winter, after the shortest day ever, then finally days start to get longer and longer and longer and longer and longer until spring equinox. And that is how our seasons work. And that is why it is warmer in the winter and or warmer in the summer and colder in the winter. Okay, so I'm gonna slide over to the slides here, just so that you could see what I put. Share. And yes, awesome. Oh, it's loading. All right, so here is a nicer picture of um, the cycle. They have it a little bit different than I had it, or kind of the same. So you can look at this picture and just listen to what I said because I did not draw the greatest things ever illustrations for you guys, but that's how it works. Same exact thing going on here. You've got your equator, you've got things going in a counterclockwise direction. You've got your seasons, your equinox at the top and bottom, the solstice on the two sides. Um, so the spring equinox usually happens around March 21st. The summer solstice after that happens around the June 21st or 2nd is going to be the longest day of the year. Then hours in the day equal up again at about September 23rd with the autumn equinox. And then start getting shorter and shorter and shorter and shorter until December 23rd or 22nd or 23rd when we have the shortest day of the year. And it's awful. So I had some quick little notes here for you guys. Solstice, equinox. Might want to write these down um, if you would like to, up to you completely. And now we're going to get into weather. So I just wanted to go over seasons first because seasons are a lot of the reason why weather changes and fluctuates all over the world. So here, the key term that you should know, this will be on your test most likely, that weather is the condition of the atmosphere in one place for a short period of time. Okay, keep that in mind, for a short period of time. All right, and then we're going to talk about conditions that affect weather. So, like I just talked about, Earth's position in relation to the sun and how much solar energy it gets and what season it is going to affect the weather, whether it's rainy or whether it's snowing and freezing cold outside and terrible like today. Unless you like the snow, then awesome. Um, that's going to affect that. The amount of water vapor in the air, which is like humidity and I don't know, water, but as a gas form, but in the air, that's going to affect how much precipitation that we receive. Then cloud cover, because clouds hold water vapor. So clouds in the sky are going to fill up and fill up and fill up and fill up with water vapor until all of a sudden it just is all like condensed together to form heavy water droplets and then rain all over the place. So obviously here in Colorado, we don't have that much water vapor in the air. because it's dry and we hardly ever get any rain. Today we're getting some snow, which is good. But in like Florida, they have tons of water vapor there. They're by an ocean, so it makes sense. Um, but yeah, so it's gonna rain all the time and it's super humid. I don't know if anyone's ever been to Florida, but crazy, crazy different. And then landforms and bodies of water are also going to affect weather. And this is because water heats up slowly, but it also cools down slowly. So if you're living by like a big lake, um, in the mountains or something, it's going to be colder for a longer time in the winter because it's going to take a long time to heat up, and that cold likeness of the water is just gonna radiate around, and make everything else feel a little bit chillier. And then this is also because land heats quickly but also cools quickly. So yes, usually if you're living by the ocean or something, you're going to have more or a body of water, like a sitting body of water. You're going to have weather that fluctuates, or at least temperature that fluctuates less than if you just live in land, like by land, no water around anywhere. So if you have questions on that, please let me know. That one's a little bit confusing, but we'll get to that more. Um, oh, I forgot to hit on that last one. There's 3 types of precipitation: convectional, orographic, and frontal. You won't really need to know this for the test, but it's kind of cool anyway. So convectional is where there's like a big cloud, like the rainforest or something. It's super humid, and that's convectional is when it's super humid and all the water vapor just goes up and just makes it rain constantly. Then what is it? Orographic is when, like, let me see if I'll stop sharing real quick. Or when there's like some water here and then some mountains, like a big mountain range. Oh God, this is just embarrassing. This is awful. So there's a mountain range, and um, the water vapor is all accumulating in this cloud here, up here. And as this cloud travels over these mountains, it's going to rain a lot and it's going to precipitate a lot. So these side of the mountains are going to be very lush and hydrated and green. And then these, by the time that the air from this side of the mountain gets to this side of the mountain, all of the water is going to be all used up. There's not going to be anything left for this side of the mountain. So it's going to be all dry and like a desert. Yeah, I'm not drawing anymore. Okay. And then we get into different types of weather extremes. So let me go ahead and share my screen again. Share my screen again. Okay, so we get into weather extremes. So like hurricanes, tornadoes, blizzards, droughts, floods. All of this depends on your place or location. 5 themes of geography. So usually warm coastal towns are going to see hurricanes a lot more often. Um, Tornadoes are like in the plains, just like some extreme weather there. And blizzards in like the Midwest and um, like New England, Northern America. Floods more towards like down south, like New Orleans. And like Florida, where there's a lot of rainfall. And think about, guys, how these extreme weather conditions and their So location gives way to extreme weather locations. How does this affect place or people's um, people like features on, you know, their location or however you want to say it. So there's location and place. Two themes of geography that we could be talking about here. In Florida, where there's a lot of hurricanes and floods, you're going to see a lot of like beach houses that are maybe on stilts so that they can't get flooded as easily. In like Oklahoma or like Tornado Alley in America, where there's a lot of tornadoes and bad storms, you're going to see a lot of houses with like tornado bunkers. And that's like that becomes part of their place. People have to adapt to their environments. And that's also part of human environment interaction. So, just a little 5 themes of geography there. It's the most important part of geography. Okay, section 2 is climate. I'm going to try to breeze through this, guys. I know it's a long video and my voice hurts. So unlike weather, climate are weather patterns in a location experiences over a long period of time. So for example, Colorado has like a dry, temperate climate, but right now we have a very wet and cold. We're having very wet and cold weather outside. That's short period, climate is long period. There are 4 major factors that influence climate: wind and ocean currents, zones of latitude, elevation, and topography. I don't know if I did any slides on. Okay. So 1, wind and ocean currents. This one is really interesting and probably one of the hardest concepts to understand in terms of climate, I think. So I'm going to go ahead and bring it back to here, my whiteboard. I'm going to draw the Earth since I don't have like a map that I could point things out at. If this is just terrible, guys, just tell me and I will never do this again because I feel terrible. Okay, so we have the Earth, okay, and then we have the equator at 0 degrees. And these are, remember, lines of latitude. And then we have the North and the South Pole, which are both at 90 degrees. Okay, and then between that, we have the Tropic of Cancer and Tropic of Capricorn, and it's going to be at 3 degrees, 30 degrees, 60 degrees. Okay, so since this is 60 degrees in the northern hemisphere, we call these up here 60 degrees north and 30 degrees north and then 90 degrees north. And this is, I forgot what they call it, the one that goes up and down. Oh, so we've got the equator at 0 degrees, then we've got the poles at the 90 degrees. So they are the poles. Okay, so how, let's explain this. Okay, so how the wind patterns and ocean currents help change climate are because wind is actually a mechanism for the Earth to fill in air where it's missing. So what happens is, think of like slime, I guess, or like syrup or something. When you put syrup in the microwave, and this is like the dumbest analogy ever, I'm so sorry. When you put syrup in the microwave, and warm it up, it gets really thin, right? And you can pour it all over your pancakes super easily. And that's what happens with air. So when the sun's rays are heating up a certain piece of air in the atmosphere more than others, that air kind of gets like a little looser, a little less dense. There's less air there, it expands more. So as air expands, it gets thinner. Um, and what wind does is it takes cool air, which is going to be not expanded. It's going to be still close together because when syrup's cold, it's like it's like I don't know, a lot hard. It's not as runny, it's harder to like spread all over your pancakes. And so y- the wind is actually cold air rushing to that spot where the hot air expanded so that there could be air in that one place. And it's super crazy. So cold air is always going to flow toward warm air. Um, Wherever that may be, okay? So we're going to start at the equator. Let's start at the equator. And these winds are called the northeasterly trade winds and the southeasterly trade winds. So at the equator, the southeasterly trade winds are going to flow toward the left. And the northeasterly trade winds are going to flow in the opposite direction because the wind is trying to fill the spots of air. So they're always going toward each other. Okay, and so then we have the westerlies. So westerlies are going to be going um, away because there's already air coming to, so like you see 0 and 30, there's air from this 0 and 30 coming here and vice versa. This air is like going toward each other. It's replacing each other. And so what needs to happen is the air here and the air here needs to replace each other as well. So there you go. So um for example, down here toward the equator, there's like South America, and the weather in South America is pretty nice. It's towards the equator, right? So not only is it warm, but it has this air replacing each other all the time. That affects weather patterns because it affects clouds and it affects precipitation. And so wind has a lot of impact on all of that. Okay, so that is wind and trade winds. And polar easterlies, westerlies, northern easterly, and southeasterly. And I will try to post another YouTube video that goes along with this that you could see everything a little bit better. Okay, and then the ocean currents are basically the same thing. They're like ocean currents are like rivers that are flowing in the ocean, and there's warm ones and there's cold ones. So they usually flow in more circular patterns, but they usually try to replace itself. Um, so cold ocean currents tend to flow toward warm ocean currents, but it's not perfect and it doesn't always replace each other because unlike the trade winds, ocean currents flow in a more circular manner. Um, this isn't going to be on your test, but it's cool to know. When a cold ocean current is flowing next to a body of water or a coast, the air tends to be drier because of the colder water. There's not going to be as much moisture in the air. So that's why in North America, actually, I am going to try to draw North America. Let's see. Okay, so this is I'm just gonna draw California. This is California. Cali. This is Cali. Not the best Cali, but anyway, this is Cali. There is an ocean current actually that flows like this right against California. Because you would think California is closer to the equator. Not super close, but getting there. It's close to the ocean. You'd think California would be like have a lot of like precipitation all the time, but no. California is in a drought. They're dry. It's desert in California. And that's because this is a cold ocean current that's flowing right past California's coast. So that causes the air to be drier. That causes the air to be cooler. There's not much moisture, so there's going to be less precipitation, and it's all because of the ocean. So that is some interesting stuff. Okay, then we've got zones of latitude. So I'm going to draw the Earth again. This is going to be 0 degrees latitude, which is what is at 0 degrees latitude? The equator. The equator is at 0 degrees latitude. And then the poles are at 90 degrees latitude. So if the North Pole is super cold and the South Pole is super cold and the equator, all of this is like warm, like luscious land, and then this up here and down here is just freezing, then what does that mean? As latitude increases, temperature decreases. That's the biggest thing to remember. The next thing that affects climate is altitude. Same thing with altitude. For every 1,000 feet that you go up in altitude, which is your distance above sea level. So like Denver's the mile high city. That's because their altitude is a mile above sea level. So with every 100 feet, the temperature decreases by 3.5 degrees Fahrenheit. Okay. And so what's really cool about altitude and latitude is that latitude equals altitude. And this is something that one of my geography professors taught me in college, and I never put it together until then. Latitude equals altitude in terms of climate. So the higher you get, like in the mountains, like the Himalayas, right? Or Mount Kilimanjaro is in Africa. Eastern Africa should be hot there, right? It's hot in Africa. It's dry in Africa. But Mount Kilimanjaro is so high in altitude, it's so cold that it has snow on it all year long. Okay? So, even though you might not be high in latitude, if you're high in altitude, you'll have the same climate patterns as you would if you were high in latitude. So I hope that makes sense. So that's why like Mount Kilimanjaro feels like Canada, like it's cold. So and you could find the same vegetation, the same types of animals, well, depending on your whereabouts on the earth. But yeah. And then topography, or like landforms like mountains and stuff, that affects climate because of what I said before. Like I showed you with the awful the awful ocean and the awful mountains. I don't want to draw it again, but I will. So, awful. Mountains, ocean. Precipitation. This is your cloud. And it's filling up with water vapor. And the winds are blowing this across this mountain. And it's raining a ton on this side. But as the winds push the cloud all the way over here, it probably is not even going to be a cloud, to be honest. But if it is a cloud, it's going to be super sad because there's not going to be any water vapor in it. And this side of the mountain is just going to be pure desert. So that's how landforms affect climate. Okay, so the next thing that I want to go over and the final thing are changes in climate. So climate changes over time, and scientists have been studying ice core samples from thousands of years ago and noticed a variety of changes in temperature and precipitation over the last thousands of years. And a lot of this could be due to human behavior and greenhouse gases and global warming, which I think you all are very aware of on your 5 themes of geography. Um, Human environment interaction. A lot of you said, vehicles um, hurts the earth like immensely, and our carbon footprint just in general, that causes global warming. There's also some natural changes that change the climate. One of them is called El Nino. I forgot to put this in my slide, but I'll write it down for you. This one is going to be on your study guide. El Nino. And that is a natural change in climate that happens about every 72 years. And that happens because the easterly winds that we talked about at the equator. So, okay, so we have the winds here blowing against each other. So what happens is they blow over like the central Pacific Ocean. The ones that blow over the central Pacific Ocean, they reverse direction for some reason, and nobody really knows why. But they'll just start blowing in some different way. And it's just, I don't know, it's weird. And so in El Nino years, warm ocean water is going to be pushed more towards like Asia, and we're going to experience heavy rains in America, and weather is just going to be all whack in a ton of different ways. It's just going to be nuts, all because the wind just like changed. And there's not really any like explanation to it, I don't think. I haven't found one anyway. Um, and then the reverse thing occurs when with El Nino when or La Nina when warmer water is pushed more towards the Pacific Rim. So um, El Nino is when let me see is when seasonal rains push warm water toward Asia away from the Pacific Ocean. So they push towards Asia. La Nina is when warm waters are pushed toward the Pacific Rim. And during La Nina, dryness occurs along Pacific coasts and the Americas, whereas El Nino is the opposite. America gets a lot of rain on El Nino years. I think the last one was like in like 2003 or something, and there were just like crazy blizzards in Denver, and just like and people were just getting snowed in who had like never gotten snowed in before. It was just Like I said, it was nuts. It was weird. It's just like weird stuff that happens. And then, yeah, global warming and the greenhouse effect are another reason for climate change. The earth has changed so much. Sea levels are rising, glaciers are melting, tons of crazy stuff that I won't take up too much of your time on. If the board was reflected in a weird way, I'll try to find pictures to post for you guys. I'll try to find a YouTube video for you guys to watch, a fun one, not a boring lecture one. And yeah, comment like, I don't know, something funny, like private comment something funny when I post this link. Like something funny, but like appropriate so that I know that you actually watched this and took notes. Like comment like, I don't know, just like a funny word, a funny random word. That'll be great. Private comment it though, so people don't catch on. But if you watch this, I appreciate that. Anyway, email me if you have any questions about this, about any of this material. And next lecture, we will go over world climate regions and vegetation. So with that, have a good night.